Now we see that on the periodic table we have some special groups, and we see that group 18 is a very special group. It is called the noble gases. And one thing we need to know about the noble gases is that they are very, very stable, meaning they do not like to react with anything else. They already have their octet, their 8 electrons, so they don't want to mess with anybody. They're very stable, and they're very, very unreactive. Now, if you need help by looking at the other groups on the periodic table, you can check out the video, Periodic Families iPod Lab, and this is the link for that. Just click on that, and that will give you a lot more detailed information about the groups or the families on the periodic table. Now, in looking at the periodic table, it does give us a lot of information. One thing it does is we can see trends on it, specifically ionization energy. We see that ionization energy increases across a period and decreases down a column. So basically what we see is ionization energy increases as we get closer to up to helium. And what we see is ionization energy is how much energy it takes to create that ion to give it an electron. And we see that electron affinity is the energy change when an electron is added to the gaseous neutral. So over here, ionization energy, we're making an ion, we're taking that ion away, or taking that electron away, and then we see that electron affinity is when we add an electron to it. Okay, so the other one we're taking it away, electron affinity we're adding to it, but either way they have the same trend. They increase to the same way they increase to helium. Now, electronegativity we talk a lot about in the previous chapters, and we talk a lot about now. Remember that electronegativity is a measure of how strongly an atom attracts electrons when it's in a compound. Main thing is when it's in a compound, they are not alone at all. They are bonded to something. And fluorine has the highest electronegativity, and it has an overall electronegativity of 4.0. And we see that it increases up to fluorine as well, so everything's getting higher towards fluorine. So we see that ionization energy when we take that electron away, electron affinity when we add that electron, and electronegativity all increase toward the same direction. Remember, electronegativity is how much an atom pulls when it's bonded. And then we see atomic radius, it decreases in the exact opposite way, and we see it decreases as we get closer to the bottom. And we see that atomic radius is just how it sounds. It is just the how large an atom is. And they measure that by going from a central of the nucleus to another half of the difference between two bonded atoms that are together. Now, specific ions that we have cations and anions, and cations have a positive ion. It's caused by an atom losing an electron. And these guys, main things with cations, that they are metals. And we see that anions are negative. Okay, so cations have a T, that they are positive. Anions have an N, they are negative. And they're negative because they gained an electron. Cations are positive because they lost an electron. It's a good thing to give things away. It's a bad thing to just be a taker and always take. Okay, so positive, it's good to give away. Negative, it's bad to take. So positive, negative, that's what we need to know about ions. Now, when we get into your review now, we talk about naming compounds. If we have any questions on naming, we need to refer to the naming compounds practice problem, and this is the link for that you can go on and watch a video about naming. Same thing with formula mass. We see that formula mass, if you have any question with that, that's how we add up everything. You need to watch the second half of this video. The first half is the average atomic mass, and you don't need that for your test. You just need the gram formula mass, and you'll see that in this link below. Now, in dealing with chemical bonds, we say that the atoms, that they don't want to exist alone. The whole reason why something will bond is because they want to become more stable. They want to have less potential energy. So what a chemical bond is a mutual electrical attraction between the nuclei and the valence electrons of different atoms that bind the atoms together. Okay, chemical bond is when two atoms are bonded together because of those valence electrons. And we see that we have two specific bonds that we talked about. We talked about ionic and covalent. Now, the main thing and the main difference between ionic and covalent, ionic, we see that we have the transferring of electrons. Covalent, we have the sharing of electrons. Remember, covalent needs the 8, it needs the octet. And with ionic, we're just transferring those electrons on down. The main thing, one of the main things we need to know is that ionic is between a metal and a non-metal. And we see that covalent is between a non-metal and a non-metal. Okay, so ionic, metal, non-metal, covalent, non-metal, non-metal. And we see we have the transferring of electrons in ionic, and we have the sharing of electrons in covalent. Okay, and another way that we can tell if something is ionic or covalent, or we see that covalent is broken up into polar covalent and non-polar covalent. Specifically, polar covalent, we're dealing with anything that has 0.3 to 1.7 difference in electronegativity. So we basically take the electronegativities of both of them and subtract them and get the difference. And if it falls within that region, it's polar covalent. Non-polar covalent is from 0 to 0.3. Main thing here, guys, non-polar covalent is always bonded to itself. Okay, non-polar covalent, if you see something bonded to itself, you know it's non-polar covalent. If not, we got to check out and look at the math at everything. Moving on to the octet rule, and we see that what an octet rule is it represents all elements sharing 8 valence electrons, and we see that a compound tends to form that each atom has 8 or an octet of electrons in its highest energy level by gaining, losing, or sharing electrons. So we see that everything needs 8, everything needs to have 8. So when we're looking at those Lewis structures, remember that we always look around and see if those covalent compounds have 8 valence electrons, because they need to have 8 valence electrons, because 8 is the magic number. Okay, and then we see, for exceptions to that, we see that the duet rule, which applies to hydrogen, helium, and those guys only need 2. But everything else needs 8 because they have to have 8 to be happy. Now, when we're looking at Lewis structures, and we need to know what goes in the middle of a Lewis structure. Remember that carbon always goes in the middle of a Lewis structure. Hydrogen will never go in the middle of the Lewis structure. And the least electronegative, meaning the one that's farthest away from fluorine, if we don't have hydrogen or we don't have carbon, which we can put on the outside, then we always go with the least electronegative to put in the middle. Now, if we have any questions on Lewis structures, guys, there's a good video here for Lewis structures. It's on YouTube. Just paste that in there and go ahead and look at a YouTube video on the Lewis structures practice problems. Guys, looking at ionic characteristics, the higher the difference in electronegativity, the more ionic something is. The lower the difference in electronegativity, the least ionic it is. And that goes back to our chart, remember, of ionic, polar covalent, and non-polar covalent. Guys, percent composition we just went over. So we should have an idea. If we don't, there's a video for it for percent comp. It's on this link right here. Just go watch it. You'll learn all about percent composition. Same thing for empirical and molecular formulas. You can go on here. It's just the video that has empirical formulas and molecular formulas, and this is the link for it. Guys, if you have any other questions, make sure you come in and ask me before your final. Make sure we study hard. Remember, it's 20% of your grade. Good luck, guys.